Okay, let's start to read this table, B1. Okay, then I have another form of T tables. I'll show you both. Okay, you may have different format of T table. Okay, this is the one we have it. We check our textbook first. Okay, for the first column, there's a one-sided 10%. And since T distribution is symmetric, so, okay, I'll show it here. T distribution, okay? And especially, I will use it 20 degrees of freedom, okay? And so look at degrees of freedom equal to 20. If I say one-sided 10%, means one-sided, either right-hand side or left-hand side. Okay? And remember, this is a T distribution with mean equal to 0. Okay? If I say right-hand side, means here is 10%. And left-hand side is here, 10%. And since this is a symmetric, okay, with 20 degrees of freedom, and with 20 degrees of freedom, what's the value did you see from one-sided 10% or two-sided 20%? What did you see from 20 degrees of freedom? 1.325. So this means that here is 1.325. And what is this? What is this? This is symmetric. And the mean equal to 0. So what do you expect the number here? Negative 1.325. So although the table didn't show the negative values, it can be applied to the left-hand side test. Smaller than. If I wanted to check my alternative hypothesis is less than 0, I should see from the table and those numbers with smaller than 0, I should check with this side and put the negative side. Negative number from the table, you read it. You see what I'm saying here? So although the table shows the positive, it can be applied to negative because the distribution of the T table, the distribution of the T is symmetric. And you will see that if my degrees of 20, then if I change my degrees of freedom from 20 to 30, then the value changed, right? And one thing I have to remind you that all the value in this table is called critical value. And this, when we say critical value, is referred to specific level of significance. Just show it here, like 10%, 5%, 2.5%, 1%, 0.5% in terms of one-sided. Understand what I'm saying here? All these are called critical value in terms of specific level of significance. It means that we don't have all of them, just some certain specified significance level. And again, we say that in business research, 10% is allowable, right? Whatever 10%, lower than 10%, if you said the alpha level is lower than 10%, okay, nowadays the popular alpha level is 10%, 5%, and 1%, which you all can find it critical value from the table. All right? If I change my degrees of freedom from 20 to 30, what's the critical value change? It's getting smaller or bigger? getting smaller, right? So when I say if I have 30%, the critical value turn out to be 1.31. So it's something like here, 1.31. Why? Because the more degrees of freedom means more sample size. You know, degrees of freedom, this one is equal to the sample size minus k. K is number of x variable including constant. So if you have more sample size, the degrees of freedom is bigger. When we have more sample size means what? Means the distribution will getting more steeper. Okay? When it getting more steeper, then in terms of the same tail area, then the number will getting smaller. Okay? So, and this is some other popular form of the T distribution. Okay? And look at this one. This is what we call area in the upper tail. What do you mean by in the upper tail? Means the right-hand side. Okay? So again, let's see. Degrees of freedom is 20. Okay? For 20. And area in the upper tail for 10% is 1.325. It's the same as this one. And this is just one-sided since area in the upper tail. And this table also shows that in the area in the lower tail was 20 degrees of freedom, and this is turned out to be negative 1.325. And this is also called two-sided is 20%. Therefore, we have one-sided 10% and two-sided 20%. They're put in the same column because they're same critical value. So do you know how to read this table? And from the second column to the last column is based on different level of significance. So when you recheck with the critical value from table in our textbook, from our textbook, you can read like this way. If you have different format of T distribution table, is something like this one. Okay, if you refer to any other textbook, they may have the T distribution table is like this one. You see what I'm saying here? Okay, so the why we want to check with the T tables, you have to recognize this is all called critical values because it is referred to the specified level of significance. Okay, and this is called test statistic. Okay, the test statistic is using the sample data and using the beta 1 hat divided by the standard error of the beta, then come up with the value is called test statistic. And it is also T distribution. And we wanted to compare this test statistic with the critical value. Okay, so for example here, if I'm using the right-hand side, okay, means I'm checking with alternative hypothesis is beta 1 greater than 0. Okay, and this is the, so level of significance is the criteria. They also tell us the critical value. They not only tell us the critical value, but also tell us the non-reject and reject region. So in other words, if your test the statistic by using these formulas falls on the area which is somewhere here, this is allowable type 1 error. Okay? And if your test statistic is somewhere here, how do you think this, since this is from this one, right? So we want to check whether it is greater than 0 or not. If there's a 1 t-values is here, it means this part is called rejection region. This is called non-rejection region. So you can think about this way. If you have the test statistics fall on the non-rejection region, you can think about that is too close to 0. And I really wanted to have which one is greater than 0. So if you have one falls on the rejection region, means that beta is big enough to far away from 0. Therefore, when we say the rejection region means reject what? Reject the null hypothesis. And we support alternative hypothesis. So your data is really falls on the rejection region. And the criteria to decide the rejection region and non-rejection region is the level, the critical value of the level significance. Because level of significance is the type 1 error. We already set allowable type 1 error. And this is what we say critical value approach. And in this book, the author really emphasized critical value approach. Well, but from our point of view, we're using eViews, okay? The eViews output will show p-value. And what is a p-value? The p-value is the lower tail. Okay, the lower tail, the tail area of the test statistic. So if we're using p-value, since the output has the p-values, okay, there's the other approach called p-value approach. The author really emphasized on the critical value approach. But according to the output, we can also use the p-value approach. And the p-value is the area of the test statistic. So either critical value approach or p-value approach is really, it's the same thing, but, check it with different angle. Okay, I think I really has to use some examples to show so far what I have done. Okay, so I'm end up with I already get to the step 3. Okay, the step 3 here is saying that run the regression and obtain an estimated t-value or t-score. Then, number 4, apply the decision rule by comparing the calculated t-value with the critical value in order to reject or not reject the null hypothesis. Okay, so this is what I'm saying here. And this is according to the critical value approach. And this is really recommended by our author. But I will say the p-value approach too, since we can directly read it from eViews output. We don't have to check critical value. Okay, so now let me use the examples to show how to do the hypothesis testing. Okay, and I'm going to use the example which is UDI 3s, since all of you have all this data. Okay, when you review it, you can use this data to check or ask yourself whether you really understand it or not. Okay, let me show this one. Okay, I'd like all of you to run the regression about UDI 3. Would you please do that? Let's do the same thing together. Then you will get output, and from this output, then I will explain all the procedures about hypothesis testing. Okay? So would you please run the output of this one, just like I showed it here. You should have the same answers I did here. Okay? Using UDI 3. Would you please run it? We have this data from chapter 3. And you can get it from our iLearnings. 没关系，你用那个 Excel. You may also run using Excel too. Okay, if you can run it both. So our x variable is n, p, and I. And y variable is y, using the data. Okay? So do you all have this output, like what I did here? Make sure that everybody has the output just like I did. Okay? Okay, so this means that I have the multiple regression like this one, right? Okay, and since my n is the first one, so this will be the beta 1 hat, beta 2 hat, and beta 3 hat. And this column is the standard error of the beta 1, standard error of the beta 2, standard error of the beta 3. And this is what I said here. Okay? All right? Okay. So now I'm working with the beta 1. So beta 1, this is negative relationship, right? We hypothesize the negative relationship because n is the competitors, the number of competitors. If the number of competitors increase, the customer bills decrease, right? So we are working with our alternative hypothesis is beta 1 less than 0. So step 1, state null and alternative hypothesis. So this is what I did, state. In the future, if I ask you to do the assignments and working with the hypothesis testing, you need to do as what I did here, step by step. It will remind you, you won't miss any step. Okay, it's good to follow the step, right? All right? So I don't see you have any problem with the step 1, right? Okay, step 2. What is step 2? Choose the significance level, right? Which is alpha. Just make type 1 error. Set the allowable type 1 error. Okay? Step 2, set up the level of significance. This is just remind you that, the type 1 error, is this one. This is type 1 error. When reject null hypothesis, when null hypothesis is true, type 1 error. Okay, probability of making type 1 error is alpha. And the level of significance usually is smaller than 10%. So it can be 1%, 5%, or 10%. Okay? Step 3. Collect the data and calculate the test statistics. This is more specific than the one in our table, in our book. We have 4 steps. The step 1 will be run the regression and obtain estimate t-value. So here is what I show, how to calculate the test statistic. This one, test the statistic, this term, you have to remember, this is a tool. Test statistic is the tool, okay, to check with the in the hypothesis testing. Because all this test statistic, the number is getting out of sample. If you have different sample, then those numbers will be different. Okay? So in this sample, we do have beta 1 is 9074 something. So this is from output, right? So this is from the output we just have it. 9074 67. And standard error is here. Okay? Standard error is here. So divided by standard error, it turns out to be the t is negative 4.421. And what's the degrees of freedom here? I already showed this 29. How did you get the 29? We have 33 samples, n equal to 33. The k, including the constant, is 4. 32 minus 4 is 29. Okay? Now, with this test statistic, and we are working with beta 1 less than 0, tell me the critical values. Okay, if I choose 5%. So check with the critical value first. Look at the tables and check with 5% and tell me what is the critical value. Remember, this is one-sided. Okay, so when you check the table, you have to look at one-sided, right? One-sided for 5%. So one-sided, 5%. And what's the degrees of freedom? 29. Then what's the number of this? What's the value of this one? 1.699, but I'm working with left-hand sided, less than 0. So what is the critical value? Negative 1.699. Understand what I'm saying here? Okay. So here is the, the author really recommend what we call critical value approach. So I'll do this one first. Okay, the critical value, TC, is the value of test statistic that corresponds to area of alpha in the lower tail of the sampling distribution of the test statistic. Okay, so this is the lower tail of the T distribution. Then, so what do we mean by critical value? The corresponding to the level of significance. And since we're talking about the lower tail, so we put the negative sign. So you can say that critical, if that is the critical value from the left-hand side, the critical value is the largest value of the test statistic that will result in rejection the null hypothesis. So this is what I'm saying. Now we are talking about left-hand side here. So here is our rejection region. Okay, so the critical value will be the largest numbers, largest test statistic that result in rejection the null hypothesis. Whatever rejected, this one is the largest number. The rest of them is smaller than this critical value. Understand what I'm saying here? All the rejection region is on the tail area. This is on the right-hand side. This is on the left-hand side. And critical value is also test statistic, although it is corresponding to level of significance only. All these are test statistics. This is based on the samples. But this T may not corresponding to the level of significance, right? Only the test statistic corresponding to the level of significance, we call it critical value. And this is the criteria to compare, or the criteria to set rejection region and non-rejection region. So again, thinking about rejection region is in the tail side, either right-hand side or left-hand side, because it is so far away from 0 in the middle. And the 0 is what we wanted to test for, right? So in the middle is always is non-rejection region. So if you have one-sided test, which is greater than 0, your rejection region will be on the right-hand side. If it is less than 0, the rejection region will be on the left-hand side. And from the T table, right-hand side is with positive signs, and left-hand side with negative signs. If you have the same degrees of freedom, the critical value is the same, just a different sign. One is positive, one is negative, because the T distribution is symmetric. Understand what I'm saying here? Okay, so here said that, for example, if we're choosing alpha is 5%, then according to the table, this critical value, this notation in our textbook for test statistic with the critical value is negative 1.699. So here means that I have the value here is negative 1.699, and the area I'm choosing is 5%. Okay? But what do I have for my t? What do I have for my test, the statistic I just calculated, is negative 4.421. So where is it? This is negative 1.699. And where is negative 4.421? It's far away from 1.699, right? So falls on the rejection region. So what do we mean by falls on the rejection region? Reject what? Reject null hypothesis. Because our conclusion is either reject null hypothesis or do not reject null hypothesis. So here, after we compare the test, the statistic with the critical value, we know that it falls on the rejection region. Therefore, we reject the null hypothesis. Okay? Let's see, go on. Okay. Then I'll skip the p-value, which I'll come back later on. They make conclusions. So I sort of increased this to 5 steps. Okay, where is this one? Since T1 is negative 4.421, which is less than 1.699. Okay, so we reject the null hypothesis. Okay, there is enough evidence to infer alternative hypothesis. This is always the statement, the formal statement we say. Okay, always reject null hypothesis or do not reject null hypothesis. Then say, if we reject null hypothesis, means we have enough evidence to infer alternative hypothesis. Always infer alternative hypothesis because this is the purpose we wanted to do, the research hypothesis. Understand what I'm saying here? Okay, this is what we call the critical value approach. Another approach also mentioned in our textbook too. Okay, this is called p-value approach. What is p-value? Okay, p-value is the probability that provides a measure of evidence against the null hypothesis provided by the sample. So p-value is an observed level of significance. So we wanted to know, look at this notation. Means probability of T1 less than, since our T1 is far away from here, negative 4.421. So the area of the P, the area of the test, the statistic, you may imagine this distribution is, really extended infinitive from, or positive infinitive or negative infinitive. Okay, but the tail will never touch with this is called number lines. But although it is very small, but there's some area. Area means probabilities. Okay, so probability of T1 less than this parts is what we call p-value. And according to the output, we don't have to calculate the p-value by ourselves. The output is already tell you this is the p-value. Okay? So we don't have to check critical value if you use p-value approach, because the computer output is provided a p-value. So in this case, how do you compare the p-value with? Compare with alpha level. If p is less than alpha level, means what? It's on the rejection region. And okay, one thing I wanted to remind you that since we run the regressions, we do not tell the computers whether we wanted to do the one-sided test or two-sided test. We didn't tell computers, right? Okay, so all the output from computer output is always two-sided. They're always working with two-sided, okay? In that case, if I wanted to have the one-sided p-value, what do? This is a two-sided probability divided by 2. And look at this number. This is so small with 4 decimal places. So even you divide it by 2, it's very, very small, right? And then our alpha is what? It's 5%. It's far away from 5%. So whenever p smaller than alpha level, then you from the chart you just see that falls on the rejection region. So therefore, I have put it here for my step 4. For the decision rule, I separate it as critical value approach and also p-value approach. You can use either way. But from the computer output, p-value approach is easier, right? Because you don't have to check with this critical value. But you have to know what is critical value. If I give you assignments, I can ask you to both ways, right? And you should know how to do in both ways. Okay? So would you like to try beta 2? From step 1 to step 5. Do it right now by yourself. Beta 2, I mean, do this one. Do this one, beta 2, this one. I just showed the negative one. Beta 1, right? Check with this one. Why don't you do the third one? Maybe it's more exciting. Well, this is two-sided, okay. Let's come back to the P, okay. I'll show you how to do the two-sided test next time, okay, since it's only 10 minutes left. So try from step 1 to step 5, working with beta 2 from step 1 to step 5, and also make the conclusions. You know, you have to do the practice. Without practicing, you don't know how to work with the hypothesis testing if I give you the assignments. And while you are working with that this exercise, and I'd like to say something about next week. Okay, you're turning assignments next week. Okay, you have the whole morning to do it from 9 to 12 o'clock. Did you see my assignments? From 9 to 12 o'clock. So as long as you upload it by 12 o'clock, that'll be fine. And we don't have any class. We don't have any in-class next week. Just turn in your assignments. And we'll do the presentation the following week. Understand what I'm saying? No class next Thursday. Do not come into the class. I won't be here. Okay, but upload your assignments 3. Case activity 3. and which is due by 12 o'clock. Okay? Is that clear to all of you? All right. And since we have 1 week off, then please review what I just teach in chapter 5. So after 2 weeks, we'll come back to this topic. I hope you all understand what we have learned. Oh, okay. 哈？都没电了，上课带着没有电的电脑。来上课干嘛？ You know, learn it step by step. And when you do the assignments or when you practice, just do as what I did. Then, in the future, it will be already your habit to do the research. You won't miss any step. Okay? But before that, you have practice by yourself. No, it's really practice is really a magic. If you don't do practicing, there's no magic. If you do the practice, all of a sudden you understand everything. Yes. Result? P-value approach. Okay. This one. This is for negative, right? But in this case, in this example, it's positive. So you want to know the right-hand side area of the p-value. Well, let me show the result here, okay? For the beta 2. Let me show the result. Beta 2, I think step 1, step 2, there's no problem, right? And T2 is, this numbers is positive 4.88. And again, this is 29 degrees of freedom, since working with the same regression. Okay, just different beta. Okay, then critical value approach is what? This critical turned out to be positive 1.699, right? Okay, so 4.88 is greater than positive 1.699. Therefore, falls on the rejection region, right? Okay, how about p-value approach? Look at this term here. Now we wanted to see the right-hand side area of the test, the statistic. Therefore, it is the probability of T2 greater than 4.88. Okay, this means that, the distribution with the mean 0 means under the null hypothesis. So this is under the null hypothesis. T2 greater than 4.88. The p-value is equal to this one. Okay, this is what I get exactly, p-values. But on the computer output, they just only 4 decimal places. Okay, then since this p compare with alpha, 5% means smaller than alpha, then reject. Okay, therefore, making the conclusions, either critical value or either critical value approach is using this one compare with the critical value, and p-value is using this one compare with the level of significance. If this one is smaller and if this one is larger, it all falls on the, look at the diagram, it all falls on the rejection region. Okay, so this is just different approach, but it will end up with the same conclusion. It won't contradict each other. It should support each other. Okay? So we reject the null hypothesis. Means there is enough evidence to infer beta 2 greater than 0. I'd like all of you go back home, review everything I teach today. Okay, if you didn't, Rachel will upload all these recordings. Watch the recordings, then do the practicing. So is this complicated? Yes. Yes. That's why I'm saying that I will make some rooms for all of you for these chapters, because you don't. Some of you may not have any backgrounds, but just accept what I say. Okay, I didn't tell anything wrong here. Okay, just accept what I said here and follow the steps. Then you will not miss any points. Then you will not make any mistakes. And if it becomes to your habit, then do the same thing when you do your thesis. This is the most important job for all of you to graduate, right? You have to do the thesis to finish the program. And I believe most of them, have to do this one. Maybe, maybe it's not regression analysis, but still they have to do the hypothesis testing. Most of you, I think. Okay? So if you don't understand these chapters, we're not able to go on anything. So this is very basic foundation, very important to all of you. All right? And next time I'm going to say the two-sided. Okay? I already covered a positive side, one-sided for positive side and negative side. And next time I'm going to talk about two-sided. This is a little bit different. Okay? All right? Do I make myself clear here? Yes.
I want to ask about the step 1 over there. Is that for every situation beta 1 has to lower or equal the null hypothesis for step 1? Yeah, alternative is fine too. Is beta 1 has to be greater than 0 every time, or it just in this case?
Now look at our example. We have 3 variables. One,
yeah.
N, by theory, it should be negative, since the more competitors, then smaller customer bills.
Okay.
Right? Do you agree with that?
Yes.
Then the second one in our example is P, population. The more people reside in the area of the restaurant, and there's more chance to go to the restaurant. So more people, more customers. Therefore, was saying that is positive. So alternative hypothesis is based on the theory. Okay? You'll remember that in chapter 3, we also say that when we do the project, we have 6 steps, right? Remember that? Nobody say yes. Okay. The first step is what? No, not collect the data. Review. Literature review. Right? What's the second step? Hypothesize the science of the relationship between the X and Y. So that's based on the theory, right? So all this is based on the theory. That's what we want to make the research for. So there's only 3 situations. One is positive, one is negative, and all of them refer to the one-sided test. And this one is two-sided. It may be positive, it may be negative. So this is two-sided. And this is also according to the theory. Right? Okay? Well, if you started to, read the chapter 5, please read the chapter 5. I know nowadays no students, seldom, and a few students like to read this textbook. But please, in this topic, read the books.
Can you give us a significant example for the two-tailed test? So,
sure.
Yeah.
Say this example. It will be two-sided test, and the significance level will be different. Okay? Critical value will be different. Okay? All right. That's for today. See you 2 weeks later.